Okay, and we are doing chemical equilibrium. In the last class, I told you Kp, Kc, the relation between Kp and Kc. What is delta N here? This delta N? It is the difference in the number of moles on the reactant side and the product side. I told you that most of the children, they do error here in delta N. So can you tell me what is delta N here? In this reaction, what is delta N? Delta N is number of moles on the product side minus reactant side. What is it? I'm audible, right? Anish, Kavya, what is it? 1. Number of moles on the product side is 1. Number of moles on the reactant side is 2. 1 minus 2 is minus 1. That is delta N. So that's how you can relate Kp and Kc. We did plenty of questions based on it in the last class. And then we were talking about how to write Kc and Kp for heterogeneous equilibrium. Like for example, for this particular reaction, this one, what is Kc expression? Kc, it is the concentration of yes, Kc is, should I take this liquid in the expression? See what's written here, solids and pure liquids are not included in the expression. Should I take it? No. So what is Kc? 1 over concentration of O2 times concentration of H2 raised to power 2. That's Kc. Right, Kavya? Now, if I say write Kp for this reaction, what is Kp? Kp is 1 over pressure of O2 times pressure of H2 raised to power 2. That is Kp. If I say, okay, for this reaction D, what's the relation between Kp and Kc? Kp equals to Kc RT raised to power delta N. You remember, children, what is Kp, Kc? Equilibrium constant. Yes, Veer, very good. Kc is equilibrium constant in terms of concentration. Kp is equilibrium constant in terms of pressure. Delta N is the difference in the number of moles on the reactant side and the product side. What is R here, children? What is R? Anyone? What is R? Shashank? Sanjeev? What is R? Universal? No, Sanjeev. Universal. You remember gas laws? There I introduce you with the R. In this equation, PV equals to nRT. Right, Sanjeev? Edit your answer. So when we have done some error in our answer, and when I'm giving you the correct answer, you're understanding it, edit it. Edit means you're doing it. Doing means you're learning it. Universal gas constant. Do you remember the value? Do you remember the value of this universal gas constant? Yeah, 8.3145. That's very good. Veer, you know, Veer is doing plenty of quizzes from last 3-4 days. My Gmail is full of quiz done by Veer. Veer and Sanjeev. Sanjeev is also doing it. Pragnya, you did few of them. You know, I'm getting mails whenever you're doing a quiz. The units are joules per mole per Kelvin. Very good, Veer. Very good. Excellent. Okay, where is Siddharth? Siddharth is not in the class today? Sanjeev, definitely. You will do very good, okay? Just be sincere. Everything will be taken care by sincerity, children. Don't worry, you have not done so many quizzes. I have shared the results with the parents. I'm so sorry for that, but I was forced to share it. But don't worry, start doing it. Start doing from today. And I will not see the score at all. I'm interested that you are doing. If you are doing questions, you may be wrong in the answer, but at least you are doing. That is more important. Okay, Siddharth is not in the class? No. Okay, so universal gas constant is this, and that is R. What is delta N in this reaction, children? Delta N? Okay, no, Veer. Can you put this some message in the direct chat? Because I don't think Veer is asking something in a direct message. He's saying he has done all the quizzes, but no, there is no error, Veer. My system is very perfect. You may not have submitted it. Okay. Now you have done plenty of them. Maybe now, if I check now your result, then it will be. I'll share the result now. I have decided that I'm going to share the results after every 15 days, twice in a month. Okay. Delta N is okay. Can we answer this question? What is delta N here? Delta N is 0 minus 2 plus 1, 3. So minus 3. So for this reaction, Kp equals to Kc RT raised to power minus 3. So we are good with this? Delta N in this case. Everybody has understood how I calculated delta N, Shashank? Okay, now the things which we have done with this equation, now you are going to do with this equation. Give me Kc expression, Kc, then Kp, then Kp equals to Kc RT raised to power delta N. Calculate delta N for this reaction. So I want answer from all of you, waiting for the answer. Mm-hmm. Okay, Shashank is saying delta N is 2. And he's right, perfect. What's the Kc expression, Shashank? Very good, very good. Delta N is 2. Very good, Veer. What is Kc expression? Okay, Kavya, there is error. It's written here clearly. Keep practicing this. Don't do this error. Kavya, edit your answer. Check your error. I've already indicated what can be the error. So Kavya, I'm not telling you your error. You just edit your answer. Solids, pure liquids are never the part of the expression. Yes, Kc is just the concentration of H2 raised to power 2. Yes, yes, Riya. Sanjeev, good. No, in the numerator. In the numerator. Products are in the numerator, Sanjeev. And reactants are in the denominator. Remember that? Yeah. See, when you are doing error, edit it. Yes, yes, yeah. Very good. What is Kp then, children? Now type Kp. Kavya, good. Type Kp. What is Kp? Pragnya, you're not answering, dear. Kp. Kp is only in terms of pressure of gas. Solids, liquid, this solid is not the part. So Kp is pressure of H2, write P, pH2. I know you people are hesitant in writing Kp. Pressure P, H2 raised to power 2. Raised to power 2, Pragnya. This 2. Edit your answer. Yeah, but Sanjeev, raised to power 2, this coefficient 2. Like this 2 is there, this coefficient is there. We are not going to write like this, we are going to write like this. Raised to power 2. Okay. When you are typing, you can write P raised to power, you know, this is there in the keyboard. You can put this and then write 2. Yeah, Sanjeev, your answer is right. Pragnya, good. So children, this is very important that you should know how to write concentration also. So what is the symbol for concentration? Square brackets. Square brackets. That's the symbol for concentration, right? Okay, I'm going to clear it. So what is Kc expression for this? For this reaction, Kc? For this reaction. And what is Kp? And what is delta N? For this one. Kavya, you're right. Concentration of CO2, that is Kc and Kp. Yes, very good, Shashank. Pragnya, good. And what is Kp? Kp is pressure of CO2. Yes, pressure P. Yeah, Shashank, good. Okay, now Kc, Kp, Qc, Qp, they don't have any units. No units. Okay, remember that because you're going to learn different types of equilibrium constant. Right now, I'm just teaching you Kc and Kp. Very soon, I will teach you about Kw, then Ka, unit 8, then Kb, then Ksp. Can you see so many Ks? All these are equilibrium constants. All of them. Kc for concentration, pressures, Kw for water, Ka for acid dissociation, Kb for base, Ksp solubility product. There are more. Kf formation constant, Kd dissociation constant. These are not there in our learning part, but there are plenty of any reaction, any specific reaction. The Ks have, some Ks are very specific. They have specific names like Kw is for water, for auto ionization of water, but you're going to learn it. You're going to learn all these. No units. No units. This is the rule they have given us. So don't try to work out any unit for any K. Same with Q, QC, QP, Q, oh, there's no QW, QA, QB, QSP. There's no unit for them. Okay, what is delta N here, children? Delta N. Delta N is 1. Who is this? Sanjeev. Very good. Very good. Chemistry is very simple. You have to just pay attention. That's it. Okay, so now why this picture is here? The picture is indicating you that when you put calcium carbonate, this is calcium carbonate, and this is calcium oxide. Here you have placed plenty of calcium carbonate. You see the amount? You can see the amount, right? And here you have placed less amount of calcium carbonate, more amount of calcium oxide. Here less is calcium oxide, more is calcium carbonate. Doesn't matter. The pressure, the Kp value, the Kc value in both the containers is same. Count the number of moles of CO2. 1, 2, 3, 4, 5, 6 here. 6 CO2 in this container. See the pressure? This is manometer, unit 3. Manometer is used to manometer, children. Manometer. Manometer is used to measure the pressures. Check here. Can you count the number of molecules of CO2 in this container? How many CO2 molecules are there? Come in the habit of counting, looking at the molecules. Yes, we 6. 1, 2, 3, 4, 5, 6. So can I say the pressure in this container and the pressure in this container is the same? Because number of moles of the gases are same. Okay, if the pressures are same, can I say the amount of calcium carbonate and calcium oxide doesn't matter for Kp and Kc? Kp and Kc are not dependent on the amount of calcium carbonate and calcium oxide. I can say that, children. Pragnya, am I right? You can see that here calcium carbonate is more, here it is less, here calcium oxide is less, here calcium oxide is more, but pressure is same. Okay, so take care of this point that solids and pure liquids are not the part of K. They cannot change the value of K. Okay, magnitude of equilibrium constant. Ria was typing earlier that equilibrium constant K is the concentration of the products over concentration of the reactants. Raised to power their coefficients. That's what she was typing. If K is greater than 1, if K is greater than 1, what is more? The reactants or the products? Always remember, this is the ratio of the product to the reactant. If K is greater than 1, then what is more? Yes, very good, Veer. Products are more. Products are favored. Sanjeev, you're understanding this? But if K is less than 1, then what is more? Then reactants are favored. Reactants are favored. And if K equals to 1, then concentration of the product is equal to concentration of the reactant. Very good, Veer. Perfect. Good understanding. Okay, now this K greater than 1, less than 1 is called as magnitude of the equilibrium constant. No units. Look at the magnitude of K expression here for this. The magnitude of K is this. You know what is Kc here? Kc is, Sanjeev, check this, is silver amine, this complex. Don't worry about the name. I know the name. I'm in the habit of saying the name. This one, concentration of this is a complex over, this is the product. Coefficient is 1 raised to power 1 over concentration of Ag plus times concentration of ammonia raised to power 2. So Sanjeev, write it down in your notebook. Practice how to write down Kc. Do we have Kp here, children? Anyone? Can I write Kp here? Priya, can I write Kp? Veer is saying yes. Kavya, what do you think? Tashank? Veer, what do you think? What is Kp? Kp is for pressures and pressure is for gases. Do we have gases here? So no Kp, no Kp children. This reaction has no Kp. Okay, now this magnitude of K is greater than 1. So what is more at the time of reaction? What is more at the time of equilibrium? The product is more. Yes, Shashank, very good. Now look at this. Can you give me Kc expression for this? Kc expression. I'm writing here on the whiteboard. You write here in the chat or in your notebook and compare it. Compare your Kc expression. Keep doing in the notebook or in the chat. You're not listening, you're doing. Okay, now this Kc is greater than 1 or less than 1? Is less than 1. So what is more here? Ria is writing products are more, much more. Products are less, sorry. Reactants are more. N2 and O2 is very large. So reactants are more. Reactants are favored. Are favored. Here, products are favored. Which reaction is good for you? When you are working in the lab, doing a chemical reaction, what is the aim? The aim is to make the product. That's the aim. If somebody is asking me to work, okay, carry out this reaction, I'll say, okay, what do you want to make? I'll say, I want to make this, or I want to make this. So, which reaction is good for me in the lab? This one. So, this will give me a large amount of the product. When I'm working in the lab with this reaction, I will be very happy because I'll get a large amount of the product easily. But if I'm doing this one, I will be in trouble. My teacher will keep saying, oh, how come your product is so less? Then I have to explain her or him that, okay, sir, see, Kc is very low, very low. This reaction is not favored for NO. Okay, can you tell me which one is more stable here, the product or the reactant? Which one is more stable here? Always remember, equilibrium state is the most stable form of the system. If reactants are favored, then reactants are stable. That's why they are favored. There's a reason why they are favored. If products are favored, then products are stable. This product is very stable. Silver amine complex. Stable. So you're understanding the meaning of magnitude of equilibrium constant? Okay. I'm giving you one question here. We are doing one more topic with this magnitude. That is manipulating equilibrium expressions. Manipulation of the magnitude. Okay. So I'm going to teach you that concept here only. Okay. Magnitude and manipulation. I'm changing the topic, children. You can write down. Manipulation of the magnitude of the equilibrium constant. Manipulation of the magnitude of the equilibrium constant. Let's try to understand what is it. Equilibrium constant 10. Manipulation of equilibrium constant. Okay, sorry. Let's do it here. Do the correction in the spelling of manipulation. Earlier, I think I have written something wrong. Okay, A is in equilibrium with B. The value of K is 0.2, no units. And C is in equilibrium with D. The value of K is 2. Can you tell me in which reaction products are favored? In which reaction products are favored? I've given you two reaction 1 and 2. Two reactions are given, Sanjeev. In which reaction products are favored? Yeah, second reaction. Yes, Sanjeev, good. Now in reaction 1, now focus on reaction 1. In reaction 1, which one is more stable? A is more stable or B is more stable? In reaction 1, Shashank, A is more stable or B is more stable? A is more stable because A is favored here. A is favored. That's why it is more stable. Okay. Now we are starting manipulation. Manipulation means you'll understand the word. If I reverse the equation, I make it like B in equilibrium with A, the value of K will be, the new value of K will be inverse of the previous value. Why is it so? Because K here, in this case, the equilibrium constant K is concentration of B over concentration of A. But when you reverse the equation, the equilibrium constant is concentration of A over concentration of B, just the inverse of this. So this is first manipulation. You reverse the equation. On reversing the equation, the new K is the inverse of the original K. So please write on this. If I multiply the equation by some coefficient, like for example here, C is in equilibrium with D, and I multiply it by 2. It becomes 2C and 2D. The equilibrium constant K for C in equilibrium D, what is it? What is the equilibrium constant Kc here, children? In this case, C in equilibrium with D. What is the equilibrium constant? Concentration of D over concentration of C. It has this value too. What's the equilibrium constant for this one? Yeah, all of you please type the equilibrium constant expression for this reaction. Equilibrium constant expression for this reaction. Pragnya, Anish, you're not answering anything. Anish, you are there? You didn't answer anything, Anish. Write on the K expression for this reaction. Okay. You ask your questions if something is not clear. Listening is not the option. Oh, then start asking questions. No problem. We all are there to help you. Okay. I think I uploaded the videos. Only one video is not there. Watch the videos. No answer? What is the K expression for this reaction, Shashank? Yes, Kavya. It is the concentration of D. Yes, Pragnya, good. Over concentration of C raised to power 2. Where are you? And now this value, if you see, this is nothing but concentration of D over concentration of C raised to the whole raised to power 2, which is 4. So new K is K squared because you multiply it by 2. So it is 4. So write down the next rule. If we multiply we're okay with this? So this is rule number 1. This is rule number 2. I'm giving you rule number 3. Rule number 3 is, these are multiple choice questions, children, very popular questions, very easy also, very easy. Rule number 3, A is in equilibrium with B, C is in equilibrium with D. If I say K1 for A in equilibrium with B is concentration of B over concentration of A, K2 is concentration of D over concentration of C. You're okay till now? You add these reactions, add them. Add reactions. When you add reactions, then you are getting A plus C in equilibrium with B and D. Like this. This is the new reaction after addition. You can see it, children? Is it visible? What I have written here. So I'm getting this equation after adding them. Can you write down the K expression for this? Yes, please. All of you give me the K expression for this reaction. K expression. Pragnya, Ria, Sanjeev, Kavya is ready with the answer. Anyone else? It is the constant because sometimes some children they write plus. Yes, Veer. Yes, Pragnya. Sanjeev, where is your answer? Concentration of B times concentration of D over concentration of A times concentration of C. Very good, Anish. Good. Okay, now can I multiply K1 and K2 here? Just multiply K1 and K2. Check what are you getting if you multiply these two. If we multiply K1 and K2, I'm getting the same thing. Concentration of B over A, this is K1, times concentration of D over concentration of C. This is K2. Can you see I'm getting the same thing? Which is K, the new K of the added equation. So write down this rule, children. Rule number 3. I'm giving you rule number 3 here. Add two reactions. The new K will be 2, 3, 4, whatever number of reactions are added. The new K will be the product of the equilibrium constant for every reaction. Write on this. I'm repeating the rules because we are going to do one question now. If I reverse the equation, the new K will be inverse of the original equation if I reverse it. A to B, I'm reversing B to A. If I multiply by any factor n can be 1, 2, 3, 4, it can be 1 over 2, it can be 2 over 3, something, any factor, okay? Then the new K will be K raised to power n, that factor, raised to power, exponential. If you add reactions, you're adding two reactions, three reactions, four reactions. The new K will be the product of the equilibrium constants of every reaction. Ready for the questions now? And here are questions. Pick up your calculators, children, and answer A part. Compare it with equation 1 and 2. What is A? What are you doing in A? Just compare. Sanjeev, A represents equation 1 or 2? You see, you have NOBR2, you have NOBR. A, this A represents which equation out of these two? But is it as such or it is reversed, Kavya? It's reversed. So what is the Kc value for this A part? The new K value will be inverse of this K1. Can I say that? Because you have reversed the equation. So the new K is the inverse of this K, which is 1 over 0.014. No units. No units, children. Let's do the B part. Now Kavya and Sanjeev are already answering. Now I want all of you. What is this, Pragnya? Is it for the B? Pragnya, your answer is for what? You stay with me, Pragnya. Okay? Do the B part. Children, if you want to answer faster than others, then stay with me and answer the question which I'm asking. Yes, Pragnya, very good. Keep moving. Now you can go to the C. Children, what is happening in B? B is again, Pragnya has already answered it. Is equation 1. And what you have done with the equation 1? You have multiplied by 2. Yes, Shashank, very good. So the new K in the B part is K1 squared. You multiplied by factor 2. And the new K will be K1 raised to power that factor. And factor is 2. Yes, good, Shashank. Very good. Let's go to the C part. Okay, what factor is there in the C part? 1 by 2. Very good. Very good. So Kc is K1. Yes, Kavya. So K1 raised to power. You know, if you multiply by factor n, then it becomes raised to power that factor n. So it is, yes, Pragnya, your answer is right. Yes, square root of K1. Yes. Okay, now let's see the D part. Pragnya is already answering it very nicely. Pragnya, good. In the D part, what are you doing? NOBr is in this reaction, Cl2 is in this reaction. So what are you doing? You're adding them. You can see BR2 cancelled. That's why there is no BR2. So you are adding equation 1 and 2. So what is new K? The new K is, if I say this is K1 and this is K2, yes, Shashank, the new K is K1 times K2. Yes, very good. Excellent. Anish, you're getting it? Yes, Veer, good. E part. What are you doing in the E part? You know, you can relate E with D. That will be easier. You can do with equation 1 and 2 also, but you can do with D also. If I say relate E with D, D is this. What are you doing in the E? Reverse and divide by 2. So what is new K? It will be reversed, means 1 over K1 times K2 raised to power, because we are dividing also by 2. We are reversing and dividing by 2. So raised to power 1 over 2. So I related it with D. But let's say you don't want to relate it. You want to relate it with 1 and 2. So you will say, oh, I added equation 1 and 2, then reversed it, and then divided by 2. I did 3 operations. Added, added means K1 and K2. Reversed, reverse means 1 over K1 and K2. Divided by 2 means raised to power 1 over 2. Yes, Pragnya, good. So that's the manipulation of equilibrium constant values. These are very important questions and they are generally in the form of MCQs. Anish, is it clear? Anything which was not clear here? Anish? Okay. Okay, now the most important part is the Rice table. The Rice tables which you are going to learn here will continue in Unit 8 and in Unit 9. Yes, Pragnya, but today Siddharth is not here. Otherwise, you know that Siddharth is the one who is answering for every time he is the first one to answer. And then you people keep saying, oh, he already answered it. So that's why I didn't answer. That's why I was asking. Right now, you can just answer your questions in the normal journal chat. Okay. Like generally, Siddharth is already, I'm saying the question, and by the time he typed the answer. So I asked Siddharth to go in the direct chat. You can answer in journal chat. Everybody is answering in journal chat. Pragnya? Pragnya is asking, can I answer in journal chat? So start answering in journal chat today. When Siddharth will be there, I'll ask you to go in the direct chat. For some questions, I can ask you to answer directly, but otherwise, journal chat. Okay, children, we are learning a very important concept. Anish, you can understand here only. Sanjeev, you are going to help me? Sanjeev, you are helping me in this new concept? Are you there, Sanjeev? Your hands should be on the chat. Sanjeev, Veer, Sanjeev and Veer. Okay, Veer is here. Sanjeev, where are you? Okay, okay, good, Sanjeev. You are helping me here, okay? Eyes here. So all of you are helping me in understanding this new concept. I'll ask very simple questions. When I'm teaching you this, I'll ask you very simple question. Keep answering here to understand this concept. Rice table. This is the graph of concentration versus time. These graphs are very important. Very important. Concentration versus time. Time. This time is, what's the value of this time? 0. And I'm going to call it as initial. Initial. And what has happened here? What has happened here, children? There is no further change in the concentration. So this part represents, yes, please answer. This part represents that there is equilibrium. Sanjeev, you are getting it? Remember, I introduced the equilibrium as when there is no further change in the concentration of the reactants and the products. This is equilibrium. Okay, now what is this? This part? Can I say this part as Veer? What is it? Can I say change? Change. Initial, change, equilibrium. Initial, change, equilibrium. And reaction. Can you see rice? What is the reaction here? The reactant is N2, NO2. NO2 is the reactant and the product is N2O4. Please answer my question. Why did I say the reactant is NO2? Why did I say the reactant is NO2? Yes, Pragnya. See initial. At the time of initial, which one is zero? Yeah, product is zero. N2O4 is zero at the time initial. So it means it is the product. It is not formed when the time is zero, when you just started the experiment, reaction has not started. When the reaction has not started, you have only NO2, right? This is NO2. This is N2O4. Can you see the rice here? Reaction, initial, change, equilibrium. Okay. In this graph, which part is the most stable part of the system? Which part is the most stable part, Anish? In this graph, which part is very stable? The equilibrium. Yes, very good. Can you explain why the system is undergoing a change? Why this change is happening? Because nature is always driving us in the direction of stability. You know, we all are working hard. Even you kids are working hard more than us because you want to be stable in life. You want to have some good jobs and everything. That's the law of the nature. Nature is forcing us to work hard so that we can become stable, comfortable. Yes, Sanjeev, very good language. The concentrations are shifting. That's what he's saying. The concentrations are changing, shifting. Shifting word is very good word here because these concentrations are changing to come in equilibrium, to come in the stable form, right? When it is equilibrium, I'm going to say K, equilibrium constant K, which is, can you give me the expression of K here, children? What is the expression of K for this reaction? What is K? It is concentration of N2O4, the product, divided by, Anish, concentration of NO2 raised to power 2. This coefficient 2. That is K. This is K here, children. This part is representing K, the equilibrium part. Is K. But what is this part then? What is this? Here. Starting from here up to here. What is it? Q. Yes, Sanjeev. Good. Q is, what is Q, children? Q is non-equilibrium. Non-equilibrium. It is the struggling position. You can see it's written here. Q is non-equilibrium. It is the struggling position for the system. System is struggling here to become stable. But what is the expression for Q for this reaction? Q also has the same expression, same as K. Concentration of N2O4 over concentration of NO2 raised to power 2. Same expression, children, same. These two are same. But Q is not an equilibrium, so the value of Q may be not equal to K, right? The other name for the Q is reaction quotient. That's the other name. It's just the ratio. Its expression is exactly same as K. No units for Q. No units for K. Okay, now check here. At the time of equilibrium, when it is very stable, your K is equal to Q. Q and K, they have the same magnitude. But before that, in this part, the value of Q is different. It can be high, it can be low. You're understanding the word Q, everybody? Q is a non-equilibrium state, very unstable, and it wants to become K. It has the same expression as K. Reaction is always shifting the way Sanjeev has written, shifting. The reaction will shift in the direction of the product or reactant. It can go in either direction depending upon Q. If Q is big, if Q is small. But when Q becomes equal to K, then it's stable. Then it is equilibrium. Yeah, we are good with this? Yes, Ria? Ria, are you there? Children, please don't leave the chair without telling me. Ria, you're there? Because it's not good if you leave the class without telling me and I'm calling your name. Okay, Kavya, you're there? Okay, good. Okay, fine. Now I'm giving you one reaction here. A is in equilibrium with B and the value of K is 10. But I started the reaction, I started with A and B, and I calculate the value of Q as 0.1. So the system is non-equilibrium. It wants to become K. This Q is less than K. So Q has the same expression as concentration of B over concentration of A. So in which direction the reaction will shift to make this Q as K? Is it going to shift in the direction of the product or the reactant? What do you think? Q is less. It means what is less? Yes, Veer, you're there? What is less? The products are less or the reactants are less? Veer, are you there? And Ria, you're back? No. Okay, children, it's very easy that you leave the class and move away. Just think that, okay, now she's teaching. I know the thing. School teacher will. Here you have come for learning. Okay, Shashank. Please inform me when you are leaving the class. Okay, please answer this. Q is less than K. Then what is more? At the time of Q, what is more, what is less, what you are expecting in the class, in the equilibrium? Mm-hmm. Not able to answer? This is simple mathematics. Pragnya, simple mathematics. What is more here? A is more, B is less. So in which direction the reaction will shift? In the direction of B. So when Q is less than K, then reaction shifts in the direction of B, in the direction of product. Are you understanding this? Because when it goes in the direction of product, more products, Q starts increasing. You want to increase it. You want to make it 10. And once it will reach the value of 10, then equilibrium. Sanjeev, is it okay? Okay. The way I explained this, now all of you are going to explain, all of you, please try to answer. If Q is less than 10, let's say, oh, that we have done, Q is less than K. If the value of Q is 100, K is 10, Q is 100. So Q is greater than K. Q wants to become K. In which direction the equilibrium will shift, the reaction will shift? In which direction the reaction will shift? Now Q is 100. 100 means you have plenty of B. B is more, A is less. So in which direction it will shift? To the left. Yes, very good. If Q is greater than K, it means products are more, reactants are less. So it will go in the direction of the reactants. So shifts, this is very important, shifts in the direction of reactants. Or you can say left. Products, you can say right, shifting to the right. Reactant, you can say left. Reactants are always on the left side. Products are on the right side. Okay, Ria, you are back. But Ria, where were you? I was calling your name, then I sent a message on WhatsApp also. You were not on your chair, right? So please inform me when you are leaving your chair. Everybody informs me so that I should not call the name because I called your name 5, 6 times. So next time, if you leave your chair, okay, but you missed very important concept. Okay, now we are moving on. No, part of the video is okay, but how you are going to handle these questions now? Okay, ready for this question, children? Which is based on Q and K. Okay, the equilibrium constant K is given. This is the reaction. Read the question. First, you give me the K expression or Q expression. Give me the Q expression. Q. Because I will be calculating Q for all of them. For A, B, C, I will be calculating Q. What is Q expression, children? Remember that I told you Q has the same expression as K. Yes, Sanjeev, what is Q expression here? Concentration of HOCl raised to power this 2 over, yeah, but the products over reactant, very good. But let's write it down properly. Write down properly in your notebook. Write the reaction and write down Q expression. Let's do the A part. These are concentrations, HOCl. Square brackets are concentration. These are not moles. These are concentrations. Concentration means, what is the meaning of concentration, children? Anyone? Concentration of A means molarity. Means, yeah, what is molarity? Yes, Kavya, what is molarity? Moles over liter. So read the A part and tell me what is the concentration of HOCl. And plug in this expression. So please, all of you, type the concentration of HOCl. Moles are given, volume is given. So what's the concentration? Veer, what is the concentration? You are not answering now. Veer, start answering again. With units. Units are? What are the units? Yes, Veer, what is the unit of 1? Moles per liter. You can write like this, MOL. No, MOL, small, there is no E. This is the unit of mole. There is no E. Yes. What's the concentration of water? Concentration of water? Yes, anyone? Read the question, concentration of water. Yes, 0.10. This 1.0 squared, this is squared. What's the concentration of Cl2O? Concentration of Cl2O. I'm calculating Q for the A part. We are working with the A part. 1.0 squared over 0.10 concentrations of Cl2O. Same, very good. Very good, Kavya. Pragnya, you're not answering anything. So what's the final answer? What is Q? Sanjeev, Shashank, Anish. Anish, mathematically, what is the answer here? You can do it without calculator. 100. Is this Q greater than K or less than K? This Q is greater than K. So in which direction the equilibrium will shift? So what is more? If Q is greater than K, what is more at this time? Products are more. That's why Q is so big. So in which direction the equilibrium will shift? It will shift to left. Yes, Anish. Because products are more. That's why Q is so big. Now the way I have done A part, can you answer B part, children? Give me the concentration of HOCl, the concentration of Cl2O, H2O. I'm going to plug in here. Yeah, all of you please type the concentration of HOCl. Yes, very good, Kavya. 0.042. Pragnya, I'm not getting answers from you. What is the concentration of Cl2O? Is 0.040. And 0. What is the concentration of H2O? 0.49. Pick up your calculators and get the value of Q. Get the value of Q, children. Mm-hmm. Is it? Anyone else? Yeah, Kavya, see some error. Pragnya is right. 0.09. That's the answer. Yeah, that's the answer. Kavya, can you check your calculation? Is this Q greater than K or less than K or equal to K? All of you please type. Look at the value of Q and K. Q is equal to K. Any shifting here? Yes, Ria, any shifting? No shifting. System is in equilibrium. No shifting. It's already very stable with low energy, the way Anish was typing earlier. So once the system is in lowest energy, then it becomes stable. Then there is no shifting to left and right. And that is the situation when it is in equilibrium. When Q becomes equal to K, my system is in equilibrium, very stable, no shifting. Can we do the calculation for the C part? So Q equals to, get the concentration of HOCl. This time the volume is 3 liters. Okay, good. 0.0833. I have to take the square of that because this is coefficient is 2 squared divided by. What's the concentration of Cl2O? What's the concentration of water? No, Kavya? Oh, yeah, okay, 0.186. Okay, good. Now, what's the value of Q? Only Kavya is answering. All of you are relaxing? Don't relax, children. Veer, where are you? You're not answering anything now. Get the value of Q. Pick up your calculator, Veer. Plug in all these values. Get the answer. Q. Sanjeev, Q. Anish. You should not take so much time. I don't have my calculator here, otherwise. Yes, Pragnya is right. Children, we need to practice our calculator also. Is it Pragnya? Okay. Now, how many significant figures should be there in my answer? Let's work out sig figs. How many significant figures should be there in my answer? Come on, why? How many sig fig in this number? In this number? In this number? In this number? So the minimum sig fig, and you are doing just multiplication division. You are not doing addition subtraction. Answer should come in minimum significant figures. And the minimum significant figures are 2. Yes, Shashank. The answer is 110. I have to drop this complete. And no decimal. Don't put decimal. 110. So, can you work out Q? Oh, we have worked out Q. Can we compare Q with K? Compare Q with K. This time Q is greater than K. Agreed? So in which direction the equilibrium will shift? Q is greater than K. Means products are more. Reactants are less. For equilibrium, we need less products. So equilibrium will shift to left in the direction of the reactants. Equilibrium will shift to the left for reactants. Agreed? I'm going to clear it. Okay. So this is what we have done just now. And this is something which you have to practice and memorize also later on for the examination. If Q is greater than K, it will shift to left. If Q is equal to K, it is at equilibrium. If Q is less than K, it will shift to right. This is equilibrium. Q is less. Q less means products are less. So it will go in the direction of the products. Q greater. Q greater means products are more. So it will go in the direction of the reactants. And this is equilibrium. Q equals to K. This is important. And this we have to practice and memorize. This is there in my notes also. Okay, children. Now this is about the rice tables. Now questions on the rice tables have started. You already know the meaning of rice now. You know the meaning of rice? R means, I means, C means, E means. Yeah, please type here the meaning of rice. What is the meaning of R? Veer, what is the meaning of R? I explained you the meaning, right? Over here. No, Sanjeev. Only one is wrong. Sanjeev has written everything correct. Only one is wrong. Who's going to correct it? Who is going to correct it? R is reaction. Rest all he has written very accurately. Initial change. You remember the graph? There I explained you. What is this part? What is this part? E. Equilibrium. What is this part? This one? I. Initial. What is this part? This one? In between? This one? Change. This is change. Initial, change, equilibrium, and where? For any reaction. So first you will write the reaction. Then you will write the initial, change, equilibrium. Children, today I have to go somewhere. So I think I have sent you the message that the class will be shorter. So this is the new thing which I want to start, but it's better if I start it tomorrow. So tomorrow we'll be doing plenty of questions on rice table. So I'm going to cut short the class right now. And I'll see you then tomorrow and we start with the rice tables. So in case you have any questions, I will stay in the class for 5 minutes. If you have any questions, you can stay back. See you then tomorrow. Yeah, bye. Bye, Pragnya.